Thank you. Well, yeah, so I'm Ryan. I live in New York City. I work on the Instagram iOS team. And I'm really humbled and happy to be here in Singapore. First time over across the sea in Asia for me. And I love it. I love it here. And I love these conferences because they give me an opportunity to hear, not only from people on the stage, but from all of you out in the audience, different stories about the things that you're working on, the places that you work at, that you're just learning to be a developer, that you're experienced and looking for something more challenging. And these stories, I think, are so fascinating. They help me learn. And it's just a great experience to share these stories. And so I've been making kind of the rounds talking about the story of work we've been doing on Instagram, where we rewrote how our feed works, the process, the problem, the decisions that we made, the outcome, and then talking a little bit about this project that we've open sourced recently. So before I dive into kind of what this whole refactor was, I want to explain where we were. And that first starts off with this topic of tech debt. Who's ever experienced technical debt before? A massive app, spaghetti code, tons of dependencies, crazy compile times. Well, that's where we were. You know, Instagram, its feed, uses collection views. And for our collection views, we have an array of posts. And this is a typical post that you would see on Instagram, where you've got an image, some comments, some buttons. And this is all composed in a section in a collection view. And if I break it up, you've got all these different cells. And then the individual cells, so we've got at the top, we've got like a supplementary view, then the media cell, action cell, comments, et cetera, et cetera. And to put all the data in these cells, it's driven by this model called, a feed item. So this feed item contains all this data about the user, the comments, an array of comments, the URL for the media, et cetera. Now, the one problem that we had in Instagram is that to generate this section, all the data had to be inside a feed item. So we ended up with this really large object that would configure this section of cells. And everything was starting to become really hard-coded. And when teams would come to us and say, hey, we want to try to put this new unit in the feed, you know, something like a horizontal scroll view where we suggest different people for you to follow. Well, we'd ask them, you know, is this a feed item? And they're like, well, no, there's no image, there's no video. And we'd be like, sorry, can't do it. It's just too technically challenging. And that really sucks. You know, it sucks to tell teammates that, hey, due to technical debt, we actually can't build your feature. And so why were we there? Well, a little bit of a history lesson on Instagram. Instagram started back in 2010, so over 6 years ago. We just had our 6-year birthday party a couple weeks ago. And when it launched, all we had was this feed item, which were really just images. And a couple years later, we added video. And as time went on, we wanted to add more things, like users. But if you've worked on an app for any period of time, when a product manager comes to you and says, hey, we want to just add this tiny little feature, such as video, where it's still a post, it still has comments, you can still like it, but instead of downloading an image from a URL, let's stream a video from a URL. And you're like, great, well, that's pretty easy. I don't need to create a new video model for that. Instead, I'm just going to put all of this data inside my feed item. And then as time goes on, you end up with these huge God objects that just contain all of this data about everything that could possibly exist in your app. And imagine this gigantic God object powers our feed, so configuring all of those different cells. But if you're looking at Instagram, there's not just one of these. No, it's a whole list of them. And to package up all of this different logic, well, we stuffed it inside a view controller that we called feed. But us being clever engineers, one view controller was not enough. We decided that we need 4 all inheriting one from the other. And this is out of control. But why are we here? Well, Apple has this awesome concept, this awesome architecture called MVC. And just like Gwen said yesterday, what does this stand for? Massive View Controller. And we were nailing that one. Tons of massive view controllers. Each of those 4 view controllers would easily have 4,000 or 5,000 lines of code. So just crazy out of control. You wanted to make one change in one view controller, well, you might have to make changes all across the 4 of them. But in all honesty, what's the worst that can happen? And we're a world-leading app, one of the most downloaded apps, and one of the most used apps of all time. If we've got a little bit of spaghetti code and bad architecture, what's the big deal? We're still like world-leading. But then one day, you get messages at 3 in the morning. And you make mistakes. You ship bad code. And they start actually impacting people that are using your app. And we decided that enough was enough. We can't tolerate things like this, and we needed to just start from the ground up and rewrite it. So that's what we did. And one of the first things that we had to tackle was getting rid of this God object. We decided that we needed to be able to support multiple types of models in our feed. And to do that elegantly, where people could arbitrarily add data to our feed and not have to rearrange how everything worked, we decided that we had to get really clever and use diffing. If you've ever tried to use diffing, it's not the most complicated concept. You've got an array of stuff that you're coming from. You know, imagine here we have all those videos and feed items, and then we have an array that we're going to. And Collection View supports all of this stuff where you can delete, move, insert, or do whatever you want. So to do this transition, we first start off by deleting things that don't exist in the new array. We reload something, this red cell, it went from a value of 5 to cat. Then we move everything into their new position. And lastly, we insert. So we take objects that weren't there in the old array, we insert them into the new one. The only problem with this is complexity. Most naive implementations of a really good diffing algorithm that can do delete, move, insert, and reload usually run in n-squared time. And for an app like Instagram, where people are constantly reloading their feed and data is constantly coming back in, well, that's just not acceptable. It would take way too long. So we put our heads together and decided to do a little bit of math. And we found this algorithm written by a guy named Paul Heckel back in 1978. They used a concept called the longest common subsequence, where we could scan both lists of arrays and figure out all of the deletes, inserts, reloads, and moves in linear time. So we wrote this algorithm, and we're able to take all these arrays, figure out how to get in between them, and not only can we do it quickly, but since we can do it in linear time, that means we can do it on the main thread. So we don't have to deal with race conditions or anything like that. Anytime new data comes in, we can automatically diff it and apply those updates. But what about our view controllers? Well, we decided that we can just get rid of them. But if each of those view controllers has thousands of lines of code, all of that logic has to go somewhere, right? Whoop. That still left us with this problem that I like to call the world. When you create a view controller that's typically the data source of your collection view, it has to know about the state of every single one of those objects. It holds an array of feed items. It knows how to map the feed items to the sections. It knows how to take the cells within each of those sections and configure them. And that's where all of that complexity comes from. So what we did is we created this new concept where we split up all of that really tricky logic and focus on the more important parts, where it's a single model and a section of cells. Get rid of this whole concept of the world and break it down into much smaller and manageable problems. We call this concept a section controller. It's a controller just like anything else, not a view controller, but it's just an object that controls the section. So given a model, configure all of these cells. What this lets us do is build an API that returns the number of items, configures the cells, the cell size, deals with interaction, but most importantly, we're able to stuff all of the business logic of this section inside the section controller. And when we look at this, all of that business logic is contained in each of these tiny little modules. And what it lets our product teams do is they can come in and add any sort of model, any sort of section controller, and all of that logic, instead of mucking up this gigantic view controller, is tucked away. So then we were able to go back to our product team that suggested this unit and say, hey, you know what? We can do that. So they were happy. We were able to ship this feature, and everybody wins. So putting it all together, we've got this array of arbitrary data. We can feed all of this data through our infrastructure using diffing. So this data goes through our adapter, gets diffed, we generate section controllers for these different types of data, and then these section controllers can, These section controllers can then configure all of the different cells that end up in the collection view. And we get this nice unidirectional data flow that encourages you to put data in from the top and let it naturally kind of funnel down into the cells. And like I mentioned at the beginning, we open sourced a lot of this work. I'm really big on source. Obviously, Facebook is a huge open source contributor. And we asked ourselves, what can we give back from all of these problems that we solved? So take a typical collection view setup. You've got to start by subclassing the view controller. You've got to conform to the data source, register your cells, return the sections, return the items, return the cells, return the cell sizes. And then your product manager comes to you and says, like, hey, this feed looks great. But when new data comes in over the wire, how about we just insert it at the top? And you're like, yeah, that's not too bad. I can just call insert item at index path, put it up at the top of the feed, and we're done. But then a couple months later, product manager says, what about deleting some of them? That'd be kind of nice. You know, you swipe across, it deletes automatically, and all the cells kind of rearrange. It's like, all right. That's not too bad. So we insert one at the top, we delete one by swiping. Not that complicated. Then the product manager comes back. And they're like, hey, it'd be so cool if we could move and rearrange all of these different cells. If you're like me, screw it. I'm just calling reload data. And we eliminated all of this. We were able to build feeds now where we don't have to worry about doing all of these granular operations. We can still get all of the awesome animations and not have to fall back to reload data or make really easy mistakes that everybody's made before. So like I said, what can we give back? So last week we open sourced this new framework that we're incredibly proud of called IGListKit. And this is a data-driven UI collection view framework that does all of the diffing, section controller, and adapting that we talked about earlier. And I want to kind of run through some of the high-level important parts of this framework. So for starters, we've got this IG section controller. And this is that same section controller concept we talked about at the beginning. This is all that it takes to build a section controller with a cell that has a text label in it. And don't worry about trying to read all of it. We'll slice this up. But that's all it is, not a ton of code. For starters, you inherit from the IGList section controller class and conform to the section type. And that's going to give you compile time safety, no optional protocol methods or anything like that. That'll make sure you implement all of the different parts and your section controller is never going to break. Whoa. The first method is the number of items. So here we're just returning one because we want one cell in our section. But you could return as many items as you want. The next is the size. See, we've got a context object where we can figure out the size of our container. And here we're just returning a cell that's the size or the width of our container and 55 points high. Next is a method that's very unique to the section controller called this did update to object. And this is when the section controller is given one of those models that was previously diffed, and it's saying, here you go, section controller, take this model object, do something with it. And here we're just storing it in a local variable. Then the next method should be pretty familiar to anybody that's used a table view or collection view. Just dequeuing a cell, configuring it, and returning it. Here we're just setting the text on a label. And like I said, that's basically it. That's all it takes to build a section controller. But what good is a section controller without the infrastructure to power it? And that's where this class IGListAdapter comes in. That's what takes data, generates section controllers, puts all of this stuff inside a collection view. And all you really need to do to use an IGListAdapter is add a data source. And the data source has two important methods. You return an array of objects. These are these objects that power each section of the collection view, objects that'll be diffed. And you also return a section controller for each of the objects. So for example, in this data source, we're just returning an array of strings, 3 strings, nothing too fancy. Notice the return type is an array of IGListDiffable. So that's all it takes to use the diffing algorithm is this really, really tiny protocol that we include default categories so that any object automatically conforms. And then our section controller method just returns a label section controller, assuming that all the data that we're using is a string. And what does it look like? That's kind of boring. We got our 3 cells. Each of those sections has a single cell in it, and we're taking that string and setting the text label on the cell. But I mentioned multiple data types. So what if we wanted to, in between some of the cells, add a cell with a spinner? Say we tapped in the middle and we want to load some content that's missing, what we call a neck load. Well, here we can create this object that acts as a token and put it in the middle of the array. Remember, the return type's just this IGListDiffable, so it doesn't matter that you have strings or objects. As long as the objects conform to that protocol, you're fine. Then in our other data source method, we check if that item is that spinner token and return this new section controller. And if it's not, we just use that same label one. So what does that look like? Come here. There you are. So we put this spinner cell in between some of our content. But that's still kind of boring. What about all this diffing stuff that I was talking about? Well, imagine that we want to filter this array of strings based on some text input. So we have a variable where we store our filter string, and then when we return the objects, we actually filter that array of objects for that filter string. Then we set up UI search bar, and on that delegate we just store the text and we call a method on the adapter that says perform updates. And this can be animated or not animated. And what does that look like? Well, here, as I tap on the search bar and I start searching for text, all that we're doing is returning a filtered array of stuff and calling perform updates on the adapter. Under the hood, this is calling insert, move, delete, reload, et cetera, on the collection view automatically, on the main thread, in real time, super fast. But we've got tons of other features. So again, with multiple data types, we've got sections that contain horizontal and expanding lists of content. You can filter through them and just return content that you have selected. Again, the diffing just handles all of this for you and deletes and inserts things when they show up in that array. You can also do embedded lists. So here we have a vertical list, a vertical IGListAdapter, and these red cells are actually horizontal IGListAdapters. So that same diffing and diffing behavior you get vertically and horizontally. Oh, geez. And then we've also got a concept of empty views, where if you run out of content, you can return a view that gets displayed when you run out of stuff. One of the other cool features we have is this idea of a working range. So here, this black bar represents the visible stuff that you are currently seeing. So we have 3 sections there, or 3 items. And these items on the left and right are what we call our working range, the little red box. We can specify that anything within this range gets a notification that says, hey, you are about to come on screen, or you just went off screen. And what would you use this for? Well, typically, if you've got a cell or section that has image data and it's about to come on screen, you don't want to download that image as soon as the cell comes on screen, because then you're going to see a gray box for a little bit. Instead, kick off that download before the cell comes on screen. And as you swipe through, the content's already loaded. And we have a ton of other features, a whole bunch of stuff that I have not even close to enough time to explain. But all those features aside, you might be asking yourself, why should I even use IGListKit? It's great, it works for Instagram. It seems to work fine for them. What does it mean for me? Should I actually use this? Well, I kind of summarize everything into some of our key features. Remember that flowchart where we have this unidirectional data flow. IGListKit requires you to break all of your logic into different components where you have your models, your section controllers, and your cells. And data flows from the top and goes all the way through. So it really forces you to have a much better, cleaner architecture and slim down your view controllers. It also allows you to easily add new data types to your feeds without having to check what sort of data it is, adding a whole bunch of special cell support. Instead, you just wire up your data source and create new section controllers. Also, the diffing algorithm that I mentioned before is totally decoupled from all of this infrastructure. Yes, the files are part of the framework, but if you wanted to just pull those files out and use the diffing by yourself, have at it. Also, this thing is fully unit tested, which I think is worth listing as a feature, because I think it's great that we can make changes to this project, and as long as this huge amount of tests pass, we know that everything is working just fine. Not only unit tests, but we internally have performance tests, benchmark tests, snapshot tests to make sure that everything is working as planned. And another thing that I'm really proud of is that this framework is just UI collection view. Yes, there's a little bit of an abstraction over top of it, but in the end, you end up just using UI collection view cells, and you can still set up delegates and buttons, do whatever you want, and not have to dip into weird things like C++ or having to worry about threading locking patterns or anything. Also, the whole framework is written in Objective-C with a little bit of C++, but don't worry. All the documentation, sample apps, and everything else are in Swift, totally compatible, using all the latest Objective-C annotations for nullability and generics and whatever. So it absolutely works. And lastly, to me, this is the most important part. We don't want you to ever have to call perform batch updates or reload data ever again. Just return data, call perform updates, and just be worry-free that your feed is going to work without crashing. Not to mention, alongside all of these unit tests that I'm talking about, since I started talking this, or since I began talking, we've executed 5.7, roughly, million diffs and batch updates out in the world. This is a framework and a tool that Instagram has fully committed to and is working phenomenally. And the last thing I'll mention is that IGListKit is built by some really awesome and talented people. And when I first gave this talk, we hadn't released the framework yet. So to me, this was like a huge accomplishment. But I think what I'm even more proud of now is that it's not just built by a bunch of Facebook engineers. This is open source. So it's built by multiple contributors. It's open. We have pull requests up now for storyboards and nibs. And we even have this concept of starter tasks where if you're interested in getting started with the project, you can go to the issue, find a really simple label, and put your first contribution up into the framework that we use and we ship every couple weeks. So, thank you all so much for coming. I'm going to be up here for the rest of the conference. I will be at our Facebook booth if you have more questions. But if anybody has any questions, I've got a few minutes now. Please let me know.
Okay, first question.
Hi Ryan, thank you for open sourcing the IGListKit. But I'm just curious, what is the difference between this and IGListKit that you just one of the contributors to?
Yeah.
Thank you.
So IGListKit is an incredibly powerful library that was built by the team working on paper so that as you are interacting with the app and scrolling, if you've never used paper, it's just full of a whole bunch of rich gestures where you can swipe and drag and drop basically any element in the UI. And in order to, how about that? All right. In order to actually have those interactions and animations at 60 frames per second, doing stuff like view sizing and rendering would have to happen on a background thread. So that's where IGListKit came from. And since that time, they've added a whole bunch of really amazing features also for things like collection view and table view. So there's a small amount of overlap, but where IGListKit was built really to solve the whole problem of a data source. And it doesn't really tell you how to size your cells or render them. In fact, we're actually working on a demo project where one of the sections in IGListKit is rendered with IGListKit. And component kit and a web view and UI kit. So you can kind of mix and match all of these things together. We don't want to dictate your UI strategy.
Hi, my question is, how do you handle the dynamic heights for each section controller that you have? Could you explain a little bit more about that?
How do we handle the dynamic types of what?
Dynamic height for the cells. Say the content could have a long height, right?
So IGListKit doesn't really dictate how you take this kind of top-level data and then configure your cells. For instance, in Instagram, we take this top-level feed item and then generate a whole bunch of view models for our individual cells from that feed item. But you could also just take a model object and then kind of manually configure each of your cells if you wanted to. But you should be able to have dynamic cells, dynamic number of cells, and then configure them however you want without any problem.
Hi. Is this working with the custom UI collection view layout?
All the demos and stuff up there work with flow layout.
Only for layout?
Yeah, it's not only flow layout. When you set up the feed, you create a collection view and you can use whatever layout you want. Within Instagram, we use both flow layout and highly customized collection view layouts. So you can do kind of whatever you want there.
Cool, thank you.
And that includes like animations and all of that stuff.
Is it on? Okay.
There you go.
You only mentioned networking briefly in the front. So how is this supposed to work with networking? Can you make one request first to load the root view and then subsequent smaller ones for later ones?
Yeah, that's a really good question. We have a couple different feeds where we have just one kind of top level network request where we go and we fetch items for the feed. We also have feeds where as you scroll to the bottom we'll make a tail load where we fetch the next page of content. But we also have feeds where one network request will give you say 10 items and then we need to make either 10 individual requests or another request kind of batching all 10 things to get some extra metadata. None of the networking stuff is built into IGListKit, but with the way diffing works and the way we kind of wrap perform batch updates on the collection view, you can call as many updates as you want on the collection view, and it does what is called coalescing, and it will kind of merge all the batch updates into a single update and then apply it once. So you can do like one big feed load and then say 10 individual loads, and they all reload the feed at the same time, but then as long as the feed isn't doing a batch update, it'll squish them all into one. Couple over here.
Hello. I have a question about diffing. So can you give more example about when do you do diffing in your library? So you have given an example that when the user do searching, then you need to do diffing, right? Are there any other example that you need to do diffing?
In the sample app, in the repository, we don't have any other examples that kind of highlight the diffing. So the framework, whenever you put something into a collection view, will always be diffing. Whenever you call perform updates, it will do that diff and figure out when something has changed. Well, actually, the one example that I showed, this one, where I'm tapping on the different segment control and filtering all of these different items, that's also doing diffing. So it's always applying this diffing algorithm. It's just kind of whatever is returned from the data source method objects for list adapter will be diffed with whatever is in the collection view right now.
We'll take in one last question. Catch Benjamin during.
Do you have any plans to rewrite with Swift of the core IGListKit?
No plans to rewrite with Swift. Instagram is 100% in Objective-C, so we need to make sure that we're using something that's totally compatible. But like I mentioned in one of the slides, everything interops with Swift just fine. I do have one, if you go to the repository and look through the issues, there's actually an issue where I'm kind of asking for somebody that's good at Swift to beat our diffing algorithm in Swift, because it's all C++ now. But I'm curious to see if using Swift would actually make it faster. But right now, there's definitely no plans to rewrite anything in Swift. But it will always be 100% compatible.
Okay, thank you, Ryan. And for the rest of you, if you have any questions, catch him during the lunch break. And thank you.
Thanks, everybody.